Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum Sponsor Pertamina melalui Pertamina Hulu Energi sebagai subholding upstream. Gold Sponsors BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver Sponsors Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze Sponsor Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo.
Okay. Greetings everyone. Good morning. Welcome to the 45th IPA Convention and Exhibition, Technical Session 2021. My name is Meta Silaban from Pertamina Hulu Rokan. Will be the session chair for session 11 with my partner.
I'm John Chung from ConocoPhillips Indonesia.
Thanks, John. So today in this session, we will have 3 presentations. In the screen, you can see that we are in the session 11, just in case you are lost. You are in the session 11, Enhanced Oil Recovery. And then we have 3 presenters. We have Pak Ilham from Ministry of Energy and Mineral Resources, Pak Jufri from Pertamina Hulu Mahakam, and Pak Aji from NRK. They talk all about enhanced oil recovery. So this is a reminder that no part of this content may be reproduced, stored in the retrieval system, or transcribed in any form or by any means, electronic or mechanical, including photocopying and recording, without the prior permission of the IPA. As a participant, next slide, you are expected to be active and participate by asking questions or comment via question and answer box. at any time during the presentation, and please address clear and related questions only. And please respect copyright by do not take any recording and screen capture from any kind of device. Without further ado, let's start with the first presentation. Okay. The first presentation titled Handil Low Salinity Water Injection, a Success Story. Okay, yeah. A success story from Handil, presented by Pak Jufri Sianturi. He's a subsurface manager Handil and Bekapai from Pertamina Hulu Mahakam. He has a degree in petroleum engineering and also magister management in 2018. He also has several publications and very active writings. He also have a professional award and recognition from the in IATMI in Middle East in this year. So congratulations, Pak Jufri. And he wrote this presentation with his co-author. We have Pak Bayu Budi Setiohandoko, Asyar Herson Surbakti, Baginda Saragi, Muhammad Ruli, Carol Sobar, all of them from Pertamina Hulu, along with Ariska Masayu Andari and Radia Senoputra. Okay, let's hear the presentation.
Dear colleagues, expert, committee, and all the audience, greeting to all of us today and praying that we are always happy and healthy. On behalf of the authors, me, Julfri Sianturi, would like to present a piece of our collaboration's work documented as Handil Low Salinity Water Injection, a Success Story. So, what is the main objective of this 15 minutes presentation? As you can see later on, it is documentation of successful peripheral low salinity injection in Handil field along with its challenges and opportunities. The presentation will be divided into 4 main chapters, which are introduction, where the general information of geological context and production history will be presented, followed by the second chapter introducing the principle of low salinity water injection. Then the third chapter describes the future project following the success story of this low salinity water injection. And of course, conclusion at the end. In the right side of the slides, I would like to invite you to see the picture of our delta environment as a tools to put a little bit context in our operations. Handil is located in Delta Mahakam, one of the 7 fields operated by Pertamina Hulu Mahakam since 2018. The field was discovered in 1974 in the inner axis of Delta along with Tambora field, where Tunu, Pechiko, and Bekapai are the fields those located in the medium axis, and Sisinubi located in the outer axis of Delta Mahakam. Handil is dominated by prodelta sediment, with mainly channel facies with around 40 km square area. Vertically, the structure field trap can be divided into 3 main accumulations, which are shallow, main, and deep zone. More than 550 individual reservoirs were identified in the field that make a complex reservoir management. The main zone of these main accumulations were 70% of the initial in-place of the field located in this zone. With low to medium aquifer support, this main zone is the target of low salinity water injection having medium to good reservoir quality. Handle production and development. The historic production of Handil field was served in the following graph. Handil field has been in operation for nearly half a decade. We can see a graph describing production of oil, gas, and water from Handil field since the beginning until very recently. The primary axis showing production rates while secondary axis indicating production accumulations. The production of the oil started in 1975 with a peak production around 200,000 barrel oil a day. Right after production, the water injection was started in 1978. The water injected was produced from dedicated water reservoir in the shallow reservoir around 500 to 1,500 meter depth. The oil production then divided into two color codes, where the light green corresponds to production oil that's supported by water injection, and the dark green is the portion of the oil from non-water injection support including shallow zone. There are variations of water injection well and reservoirs numbers, hence water quantities including two phases of gas injection period along the way, but until now peripheric water injection has been ongoing, despite on a pretty much smaller scale. A long history of the field, there were several EOR initiatives have been performed, for example, lean gas injection into the gas cap, air injection, and other initiatives. Nowadays, the field produces around 15,000 barrel oil per day with around 30 million standard cubic feet of gas. The development strategy consists of four main pillars, which are baseline, well surface interventions, new well infill, and boldness to periphery and new project. Below the graph, we can see a kind of bar chart indicating several milestones of Handil production technique, past, present, and future, from water injection to its evolution in water flooding until possibly chemical EOR in the far future. The slide describes the flow of water injection system in Handil. When it started in 1978, there was no sufficient water produced to be injected since the water cut of the field was very low. The water was produced from dedicated water reservoir at depth of 200 till 1,000 meters subsea with dedicated water producer wells supported by submersible pump. It flows to interlink water pipeline system to the water injector wells were located in the periphery of the field. The original scenario was to maintain pressure to the main zone, but by the time, with a long history, sweeping mechanism has been observed in many places. The history of the injection went up to 110 kilo barrel a day injection. Nowadays, the water injection level around 40 kilo barrel a day with associated oil productions supporting this water injection around 2,000 till 3,000 barrel oil a day. An ongoing planning to revamp the water producer in the way. It is planned to increase a water injection level up to 100 kilobarrel in 2022. Now I invite you to pay attention on the right side of the graph. It is describing a result of core flooding of the Handil using three different water, which are water produced, mixed water produced and low salinity water, and of course only low salinity water. In brief, we can see that low salinity water core flood gives a higher recovery by 10% compared to produced water. This phenomenon concluded that low salinity water injection giving more recovery and worth it to be revitalized. Referring to theory and research of low salinity water injection phenomenon, Big Daly et al. In 2016 mentioned the optimum condition for low salinity water sweeping mechanism to take place are porous medium, portion of sandstone and clay must be present. Polar oil. Refined oil will have no to minimum impact. Formation water contain divalent cation, low salinity brine. Impact has been observed in salinity until 5,000 ppm, and medium temperature MOF study are done below 130 degrees centigrade. This suits the reservoir condition of mentioned Handil. Moreover, it is identified at least 6 factors why the low salinity giving more recovery, which are migration of fine, multi-ion exchange, pH reduction or interfacial tension reduction, salting in effect, and double layer effect. We believe one of these theory or more are the main mechanism of low salinity recovery in Handil. In 2012 until 2014, laboratory experiments were performed to characterize the water that we used for water injection. It was part of a larger study of evaluation to replace the current injected water, referred as freshwater, with produced water. Water being produced as part of the oil. The idea of this replacement emerged as an effort to reduce environment impact. We present a comparison of water composition between produced water and low salinity water that we inject. Low salinity water has a range of 1,500 to 2,000 ppm, where the produced water up to 5,000 to 10,000 ppm. Core flooding was performed to evaluate the impact of different salinity to the recovery factor. 3 different scenarios of flooding were run: freshwater injection, mixture of 50% freshwater and 50% produced water, and produced water injection only. 3 different cores used to conduct these experiments. However, they were taken from the same rock facies with similar porosity and permeability. Freshwater injection shows the highest recovery factor among the 3 scenarios. The recovery factor of the 3 pore volume or PV injected can be 14% higher compared to produced water. This experiment demonstrates how different salinity affects recovery. In 2008 and 2011, we did several in situ residual oil saturation or remaining oil saturation measurement called single well tracer test, SWTT, where we inject chemical into the well with half and puff method to estimate the remaining oil near wellbore. The conclusion of this campaign gave a range of remaining oil saturations from as low as 13% up to 32%. It confirms the calculation of recovery factor from static volume to production up to more than 50% in some reservoir, even higher. Having said that, core flood, single well tracer test, and production recovery converge into the same conclusion. It strengthens our premise that low salinity water injection in Handil main zone act as chemical EOR and increase recovery significantly. Concluding the benefit of peripheral low salinity injection, now we are in progress of bringing the mechanism to the most prolific oil of the zone. Instead of peripheral injection, a study to bring the water injection into the oil pool is proposed, called unpatterned water flooding. The idea is to increase the recovery of the main zone by drilling new water injection in the middle of existing oil producers. The main challenge with the given geological setup and location of the infill well was to identify where is the sweet spot with higher oil saturation. We applied 2 methodologies, which is dynamic synthesis and validated by dynamic simulation. Dynamic synthesis is an integrated observation using 2G data, reservoir, and production to locate the most possible remaining oil area. Then in parallel, dynamic simulations with decent history matching has to have the same conclusion of the sweet spot area. Then these areas were validated and proceed with water flooding simulation to acquire stakes estimation and, of course, production forecasts. From the methodology and workflow presented before, the plan of development was proposed with perimeter of 8 reservoirs with 11 new water injector wells and 32 additional of oil producers reinstatement on top of the existing oil producer. The stakes of the project is around 7 million barrels with associated gas of more than 4 BCF. POD from SKK Migas has been obtained in Q2 2021. Soon internal FID will be granted and execution in 2022. This is one of the strategic projects of Handil and Pertamina Hulu Mahakam to support oil production of the block, in the same time to support the target of the nation's 1 million barrel production in 2030. Handil field production performance was indicating the important reduction of residual oil saturation or remaining oil saturation in some reservoir with continuous low salinity water injection. From static oil in place calculation, some reservoirs have high current oil recovery up to 50 to 80%. This was proved by in situ residual oil saturation or remaining oil saturation measurement, which was performed in 2007 and 2010. It was indicating the low residual saturation as low as 8% to 15%. This excellent result was embraced by a progressive development plan where water flooding with pattern and chemical injection will be performed later on in the future. In early 2021, production performance of this peripheral low salinity water injection support the baseline of the field with an oil production of 3,000 to 4,000 barrel oil per day with around 40,000 barrel water per day injection. The ratio of 8 to 10% of oil gain per water injected is believed the optimum performance of the water peripheral system. Now, let me conclude our sharing and collaborative work with a few sentences. First, continuous low water salinity injection benefits important reduction of residual oil saturation or remaining oil saturation. Second, Handil production performance of this peripheral low salinity water injection support the baseline of 3,000 to 4,000 barrel oil per day with around 40,000 barrel per day water injection. The third, the following success of this story as a continuation of peripheral injection, an ongoing development was initiated to inject low salinity water to 8 selected reservoirs in the oil pool, called sweet spot, in a frame of water flooding development. The identification of the area was approached based on two main methodologies, which is first, dynamic synthesis, where all the latest new wells data and production combine to summarize the current remaining oil area, and the second, we reconfirm it with dynamic simulation. The next depletion plan is expected to prolong the lifetime of the field as well as to increase the recovery of the field with the important stakes of around 7 million barrels. The fourth, integration of subsurface study, dynamic synthesis, simulations, and surface aspect is the main key success of this technology implementation. Lastly, thank you all. Hopefully this sharing benefit to all of us. I would like to thank the committee that letting us in sharing our experience in Handil field, and of course the management of Pertamina Hulu Mahakam, Pertamina Hulu Indonesia, and Pertamina. Thank you very much.
Thank you, Pak Jofri and co-authors. Wonderful presentation. We do have a number of questions. Looks like 3 questions, actually 4 now. First one, what challenges came up with injection of the low sal water during the field application? And do you have any concerns from a production or facility standpoint?
All right. Thank you, John. Thank you, Meta. I would like also to express my thankful for both of you that reshape our paper, yes, become better. But to answer the questions, the main challenges for now, I think, is more to locate it where is the remaining oil. So in the near future, as I mentioned from our presentation, there's a project that will implement the water injection into the prolific oil. So because of the layering of the reservoir, it's very complex. So that's the main challenge. But talking about the injections and also the producer, we do maintain the pressure injection so that we don't exceed the frag injections. So far, there's no damage on the reservoir. So far, there is no plugging on the reservoir. We do a kind of a whole plot to identify which is or to diagnose if there's a problem or not. But so far, there's no major problem, I would say. The same case in productions, we noticed that this is very perfect for Handil. So as I mentioned, apart from the reservoir, of course, because the field itself has been operated in nearly half a decade. So of course, the productions facility become the challenge part. We cannot maintain our pump operations in many years, but we need to anticipate. So that's the main challenge: how to coordinate all of this. We know it's good. We know it's giving something, but in the operations point of view, it's a bit difficult. So I think that's the answer for the first question, John.
Thanks, great answer. Maybe as we jump to the second question, what is the original salinity of the formation water? And given this good result of the low sal injection, have we thought about chemical injection as a follow-up?
Yeah. If you can read our paper through, so we explain this one. So the initial salinity of the formation, because it's in a main zone, is just from 1,500 till almost 3,000 meters. So it's a range of 10,000 to 15,000 ppm. Once we inject, of course, it's diluted. Now we see that the mixture of this freshwater salinity and the water formation is around 10,000 or less than 10,000 ppm. Having said that, we need to we need to anticipate further depletion of the field. So chemical water injection has been in place. So we do some research from 2010, from the previous operator, and now there's from the filtering of the selection of the COR, we see that CO2 injections one of the solution, and chemical injections. Since we don't have any source of CO2 in the vicinity, so we are proceeding now to study further and detail on the chemical injections. Chemical injection itself could be alkaline surfactant, could be alkaline surfactant polymer. It is on the study now. The budget of the study has been launched. Hopefully it will be approved soon, and we will see later on in 2024 maybe we plan for a pilot project on this chemical injection. Of course, the base of this pilot will be the 8 reservoir that we propose for unpatterned water injection, as I mentioned before.
Sounds great. Thank you. Quite a few more questions have rolled in, a lot of interest. And the next one is, what is kind of the deciding factor to add more injectors in? Just kind of seeking to understand the thought process and how do we justify type thing.
All right. Adding the more injection, because we see that the field, I'll tell you a bit of background on this one. Every year in Handil, we drill infill well around 10 to 20 wells. And every wells in main zone, we still have remaining oil. We still have oil reservoir. You know that in infill well, drainage area is maybe limited until 1,000 meter to 2,000 meter. But when we inject water into the prolific reservoir, which is in the middle of the producer, it will give us more opportunity to sweep the wells. So that's the main background why we inject more water on this reservoir. And another reason, because when we do the water injection on the peripheric, we cannot inject to the whole reservoir. As I mentioned, main zone is probably has more than 50 reservoirs. So it's very difficult to inject everything. But when we inject in the middle of the reservoir, we could probably inject more reservoir and then we produce from the existing wells. It's very economic because we don't need to drill a new wells in producer. So that's the main basic consideration, that we need to inject more, but we need to inject that water in which area. That's the challenge. As I mentioned in the previous answer, the difficulties is to find where is the prolific sweet spot for the remaining oil saturations.
Sounds great. Have a few minutes left, so let's see how many we can get through. The next question is, what's the kind of, what makes low sal outperform high sal or normal salinity?
Yeah, there's a theory on the slides that I presented before. So we believe that there are two main reasons in the Handil. Even though I have to mention it very clearly, we don't have a study very detailed on this one. We know it's success. We know it succeeded. We know it brings value. But for us now, let's go further instead of doing a particular study on that one. So we learn based on the reference. There are two main subject that there are two main theory that we believe the main mechanism in Handil, which is the interfacial reduction, which is pH, and let me check. And the multi-ion exchange. So these two particular theory, probably the main reasons why the low salinity water injections working well in Handil. Having said that, we need to aware that the mineralogy of the water, mineralogy of the reservoir, having the main characteristic that make this phenomenon works well. That's sweet in Handil. Back to you, John.
Sounds great. We probably have time for one more, I imagine. There are quite a few others. Perhaps we can add contact info and to ask further questions and answers. But the next question is, how do you differentiate kind of natural well decline, probably through normal water injection or just primary, and then injection of the low sal?
Yeah. There are several monitoring technique that we implement. The first one is to observe the pressures. As you know that from the initial, we know that if you have an aquifer or not. So when we have additional energy to the reservoir, we notice that it give the advantages of these water injections. So there's some energy. So it means there is additional energy that sweep our reservoir through the water injection. So the first one. The second one is, you see the BSW evolutions. It will be different when we have natural injections, natural depletion and water injections. And the third one will be the salinity measurement of the wells in the producer. We notice that the formation, salinity formation has some range, and when we inject something, the low salinity water will affect the salinity of the water produced. So this three category, of course, with the decline curve, we will see observation of where we have the period without water injection, and water injection will give additional bump. So this kind of monitoring, I would say, is not limited to the fourth answer that I mentioned, but so many techniques that we can use to identify that one. I think that's the last answer from that questions. John, back to you, John and Meta. Thank you very much.
Sounds great. Thank you very much, Pak Julfri, and to you and your co-authors. Wonderful presentation. Sorry we weren't able to get through to all the questions. We can coordinate through email after, but we can move on to the next topic. And so the next topic is selecting an optimum hydrophobic group from vegetable oil derivative for surfactants used in enhanced oil recovery. The author is, if we can move to the next, the author is Ilham Putra, who's the EOR researcher at Lemigas. His educational background is master's degree in synthetic organic chemistry and a bachelor's degree in analytical and material chemistry. As we can see in the previous publications, Ilham regularly contributes to publications through his work and his research. For co-authors, there are three. There's Ibu Yani Ali, who is an EOR researcher at Lemigas, Pak Usman, who is the head of exploitation at Lemigas, and Pak Didin Mujahidin he's a lecturer of chemistry at ITB. So with that, let us move on to the video. Thank you.
Hello everyone. Assalamualaikum warahmatullahi wabarakatuh. Today, I will present my presentation entitled Selecting an Optimum Hydrophobic Group from Vegetable Oil Derivative for Surfactants used in Enhanced Oil Recovery. This research conducted at Lemigas with collaboration with the Department of Chemistry at Institute Teknologi Bandung. This is the outline of my presentation today. The first, introduction, methodology, result and discussion, conclusion, and acknowledgement. Introduction. Currently, the amount of oil production in Indonesia is decreasing. Many studies have been carried out to overcome energy problem in the future. Some of the ways that the government is taking are looking for renewable energy and maximizing the production of non-renewable energy with the new technology. In petroleum sector, there are several ways to increase crude oil production, known as enhanced oil recovery. EOR technique itself is divided into three, namely thermal, gas, and chemical. Each method has certain limitations and the application is adjusted to the certain characteristic of the well. On my research is focused on enhanced oil recovery technique using chemical. More specifically, this research focused on chemical surfactant. The chemical referred to in EOR has three components such as alkali, surfactant, and polymer. Surfactant is a molecule that has lipophobic properties. In one molecule, it has part polar and non-polar. Because of this ability, surfactant has ability to dissolve oil in water. The ability of surfactant is strongly influenced by the concentration in the formation of micelle. This condition called the critical micelle concentration. Surfactant. In one molecule, it has part that like water, hydrophilic, and don't like water, hydrophobic. So, when viewed from a synthetic perspective, surfactant can be formed from carbon chain derived from fatty acid and polar part such as polyoxy group, ether and ester, sulfonate group, and sulfate group. Fatty acid, as we know, come from various types of plants such as palm, coconut, and sunflower. From this source, Indonesia has palm oil, the large community. And then palm oil contains several fatty acids such as oleic acid, linoleic acid, linolenic acid, and palmitic acid. Oleic acid is the abundant component from palm oil. Based on this abundance and support by a unique of its molecular structure, oleic acid with the carbon 18 has an internal alkane that make the typical properties of oleic acid liquid. Furthermore, oleic acid also has a carboxylic acid group. These two functional groups make this fatty acid attractive as a source of nonpolar group for surfactant synthesis. This is a general reaction of esterification. Esterification is a type of reaction that can be used to react the carboxylic acid with an alcohol. In general, the esterification reaction can be written simple. Carboxylic acid with a various type of carbon chains are react with alcohol with a various type of alcohol such as secondary, tertiary, and polyalcohol using a catalyst. This catalyst using a acid catalyst or base catalyst, where later will be produced an ester and water as a byproduct or side product. Thus, oleic acid can be combined with a polyoxy compound that has an alcohol group using a catalyst to produce an ester compound. This ester compound is kind of non-ionic surfactant. Methodology. Esterification is a two-way reaction or reversible reaction. At the beginning of the reaction, oleic acid and PEG 400 using a catalyst form PEG 400 oleate is as a main product and water as a byproduct. This reaction of formation and decomposition will continue until it reaches a reaction equilibrium, where the rate of formation will be greater than that of decomposition. To enlarge the equilibrium toward the formation of product, there are several ways to follow the Catalier principle. One way to increase the equilibrium toward the formation of product is to be reduced. And we know water is a byproduct. Reducing the water concentration of the mixed component can be done by using the isotropic technique. In this way, we can evaporate water with organic solvent, so the water can be reduced, and the reaction rate is expected to shift toward the formation of product. The tools used are the reaction flask, Dienstag, thermometer, and condenser. And the main tools is Dienstag to separate water with the organic solvent. Thus, it is expected that surfactant product with large yield will be produced, and we will get the non-ionic surfactant. To see the effect of the hydrophilic group used on the performance of the OGEP oleate surfactant, a variation of the PEG was used. And then in general, the reagent mixture was reacted for 5 until 6 hours. Then to observe the reaction using the chromatography, thin layer chromatography, if the reaction is considered an optimization of the chromatography result, it is followed by liquid-liquid extraction process and evaporation. The formed product, its structure was confirmed using the proton NMR. Products that have confirmed their structure are tests to see the performance of the surfactant. The tests carried out are the first compatibility test and the second interfacial tension measurement. Result and discussion. Esterification. This is a result, the optimum condition to synthesis surfactant with the various PEG. From the table, we can see the bigger the PEG used, the bigger the ratio of PEG needed to react with oleic acid. For every addition of 100 mess of PEG or 2 units of ethylene glycol, it is necessary to add 1 mole of PEG equivalent use. But for the PEG 1000 and PEG 15,000, the number of increment of PEG use is irregular, as for PEG 200, 300, and 400. Because the PEG unit has up to 20 until 30 times the polyethylene glycol unit. This is possible steric hydrants is large enough for the reaction to occur. Another thing is also possible because of the steric effect of the PEG molecule itself. From the table, it can be seen that the equivalent mole required for 1000 PEG and 15,000 PEG are the same. This is possible because the amount of acid catalyst used and the reaction temperature are the same for each reaction. It is necessary to add the catalyst with the higher concentration on optimum temperature to obtain the optimum condition for the 1000 PEG and 50,000 PEG react with oleic acid. Proton NMR spectrum. For example, PEG 400 oleate. LPEG oleate ester product were structurally confirmed using proton NMR. The proton NMR spectrum of the reaction product show a carbon peak attached to an alkene group with a fairly large polyoxy group in blue line. This peak indicated that the formation of the PEG 400 oleate ester from the reaction carried out has been formed. This also applies to other PEG oleate ester. The only difference is the height of peak hydrogen bond to carbon, the bind oxygen at the chemical shift of 2.5 until 3.5 ppm. The most important thing is the structure of the oleate, which initially has an alkene group at chemical shift of 5.0 until 5.5 ppm. Based on the spectrum, which is still present in the spectrum of the product form. So that the alkene group in the carbon chain of the PEG 400 oil product is still there and is not damaged during the reaction. This is a result of a surfactant compatibility test. Compatibility test is carried out to see the solubility of the surfactant in the solution or mixture. Thus, the surfactant is soluble or insoluble and form a precipitate in solution. Based on the observation, PEG 200 oleate has poor solubility and their precipitate. Precipitation occurs at the concentration 0.3 until high concentration 1%. But for other surfactant, it does not form a precipitation, even though the solution form is cloudy. This is a result of IFT for CMC surfactant. Based on observation, the surfactant that can reduce the surfactant tension of water and oil up to 10-3 dyne centimeter is the PEG 400 oleate surfactant with the polyoxy group used is PEG 400. The larger the PEG molecule from PEG 200 until PEG 400 used, the greater the value of resulting surface tension drop. However, when the large PEG molecules are used as hydrophilic group, for example 1000 PEG and 15,000 PEG, an even greater EFT value is produced. Although the addition of hydrophilic molecule can improve the solubility, but it does not have a good impact on decreasing the EFT value. Conclusion. Based on experiment and observation, can be concluded. The first, the optimum condition with the best conversion for each PEG depend on the PEG chain length. The second, the product of the reaction is confirmed using a proton NMR. Third, the IFT measurement prove that surfactant PEG 400 oleate is having the ability to lower the IFT of oil and water levels, which can be used as a candidate for chemical flooding EOR. Acknowledgement, this paper was collaboration result of Research Center for Oil and Gas Technology, LEMIGAS, and Organic Synthesis Laboratory of Chemistry, Institut Teknologi Bandung. The financial support from DIPA Research Center for Oil and Gas Technology, LEMIGAS, was fully acknowledged. Thank you for your attention.
All right. Thank you very much, Pak Ilham, to you and your team and your co-authors for a very interesting presentation. For any questions, please feel free to submit. To start off, has the surfactant been tested on a core?
Hello?
Hi, we can hear you.
Can you hear me?
Yep. Yep.
Okay. Regarding about the surfactant, to test and core, I will. It must. Bukan ini yang PEG. PEG 400 bukan dia. Udah. This surfactant cannot to test and on the core because the surfactant the compatibility and the stability, thermal stability surfactant cannot be a good value because after after the 3 day until 7 days, the IFT is decreased, and then the surfactant during so this surfactant let's see. Because the solubility is not good after 7 days. Therefore, the surfactant cannot test with the rock.
Okay, sounds great. Thank you. I guess moving on to question number 2, what is the range or temperature range of the surfactant, kind of testing the reliability of it? Or the temperature range where it's valid to be used, I guess maybe a different way to ask.
The surfactant, this surfactant study until 60 degrees Celsius to temperature. And then this surfactant cannot stable until 80 degrees Celsius.
So the maximum temperature is about 60 Celsius.
80 degree
80.
Celsius temperature. Yes.
Okay.
Okay, sounds great. There is a third question. It might be somewhat similar to the first one, but just gonna ask it and see if maybe you feel like it's slightly different. For the selecting the optimum group of surfactants in the EOR, was this PEG tested in spontaneous imbibition or perhaps core flooding test? I think you kind of addressed that. That wasn't core tested.
Can you repeat that?
Sure. Was it tested in spontaneous imbibition or perhaps in core flooding test?
Masih sama dengan yang tadi ya, berarti belum pernah dites di core ya.
The partner can be helped to answer the question.
Co-author. Yeah, go ahead.
Yes.
Yes, thank you. My name is Yani. So I am the co-author of this article. So about the question about the surfactant of vegetable oil derivatives is actually we until now. So at first, for selecting the surfactant, we have to measure whether this surfactant is good in interaction between fluid to fluid. So at first, after we synthesize the surfactant, we have to measure like the IFT, also the compatibility, the solubility, and then the filtration ratio, and so on. So for if the value or the result of this measurement is quite good, then we can continue to analyze with the core. So for imbibition, since that the imbibition is the analysis that between the fluid and the core. So I think until now we have not yet evaluate how much the recovery recovery factor of the surfactant using the imbibition test, as well as with the core flooding experiment. So because maybe it has been shown that for this surfactant, for this surfactant, the IFT is quite good for PEG 400, but it's not quite good for the others. And also we have some problem that the surfactant is not quite soluble in the brine. So I think that in the next study we have to add some like solvent or other added chemical to form the homogeneous liquid solution. Yes.
Okay, thank you. One more question. I think there's 5 minutes remaining. It's probably good timing. This question, it says potentially premature, but could sufficient quantities of the surfactant be manufactured in case we wanted to do like a pilot or a field scale type test? I'm just wondering if there's been any thoughts on the manufacturability of large volumes.
Yes, of course. For this, because for synthesizing or producing this surfactant, we use palm oil. That we know that Indonesia is one of the biggest country producing this commodity, and then for the others also for the synthesize or reaction, it's only just esterification. So I think that industry in Indonesia also quite well known about this reaction or process. So I think it's really possible to increase or to scale up the production of surfactant, of this surfactant.
Okay, sounds great.
We still have time,
Okay,
John.
thank you.
If I can ask questions, I don't know if do you want to go first, John?
Sure, I got one too. I guess what is the next step for your study? What do you want to do next to further test? I think you might have hit on a couple items, but what's your plan? I guess next step.
Yes, as I mentioned before, maybe for the next step is because the surfactant actually has the potential to be applied, and also since the source is quite abundant, so I think we have to optimize the surfactant by like adding some solvent to make this surfactant more soluble in brine. So I think that's the main problem. Because after this, if we found that this can be soluble, and then we can continue to the other analysis.
Sounds great. Maybe time for one more. Misha, do you have one?
Yes, I'm just curious. You already do compatibility test the surfactant with the oil sample. Can you elaborate more about the oil sample that you use for compatibility tests? What kind of oil type, or like APA or any properties that we can imagine how it works? The oil properties used for compatibility.
Yes, for this, in this case, we try the compatibility with the brine with the salinity at 18,000. So it's about 1.8%. And then also for the crude oil,
30-degree APA.
Yeah, 30-degree APA.
Okay. Is there any asphaltene in that oil?
Okay. Yes, there is asphaltene, but it's not in large quantity. I think. I mean, it's only like small quantity for the asphaltene. So it's not. I think that this crude oil is classified into intermediate with the low asphaltene.
Okay. Thank you, Ibu.
And also and also for the testing, we are tested in 60 degrees Celsius. So I think for the first time when we make this surfactant, it's like quite good solubility, but then after a few days, it's like there are layers. So I think then we found that we have to optimize this surfactant.
More stable. Great, thank you, Ilham and the co-authors. I think we go.
Yeah,
I think it's
you.
order 11. We go to the next presentation, the third and the last one, with the title "Achieving Indonesian Oil Production to 1 Million Barrels per Day by 2030 using nanoflooding as a novel EOR method, dreams versus reality." So this is gonna be an eye-opener for all of us. So it's written by Lucia Draningrat, Alifa, and the presenters is Muhammad Aji Pamungkas, as a researcher from NRK. He holds BSc Geological Engineering from University of Trisakti. And the co-author is Alifa Wulandari, Sabrina Tasha, Basit Valariwa, and Lucky Hendraningrat. Okay, let's hear the presentation.
Hi, my name is Muhammad Aji Pamungkas, and I'm here to represent my colleagues for presenting our research paper with title Achieving Indonesia Oil Production to 1 Million Barrels per Day by 2030 using Nanoflooding as Novel EOR Method, Dream versus Reality. The author of this paper is Dr. Lucky Hendraningrat, with co-author Ms. Alifa Hulandari, Mr. Basit Valariwa, Ms. Sabrina Tasha, and myself. And we gratefully acknowledge to Enerclub, a program by NRK that encourages energy professionals and students to collaborate and work together in conducting research on topics related to the energy industry. So the outline of this presentation will be divided into 5 sections. First, we will introduce the problem statement and the objective, and then we will describe the methodology, and then we will explain the EOR, methods, current status in worldwide and Indonesia, and also chance and the opportunity. 4 is we will intro you to the nanoflooding, the mechanism, field case, and techno-economic, and closing with concluding remarks and acknowledgement. So the first problem statement, we observed the gap oil consumption and oil production due to declining oil production as SKK Migas graphic. And based on SKK Migas data in 2019, Indonesia consumed 219 million of tons of oil equivalent and will estimated increase in 1,000 millions of tons of oil equivalent by 2050. And currently, we cannot fulfill oil consumption that increase as graphic. So, Indonesian government through SKK Migas already set 4 strategies to achieve Indonesian oil production to 1 million barrels per day. First is maintaining the base production. Second is reserve the production, change resources into reserve. Third is water flooding and EOR, focus on rock and block and screening EOR candidates. Fourth is exploration to find potential oil. These 4 strategies cannot stand alone to achieve 1 million barrels per day, but they have to have synergy between one to another strategies. And this presentation we will focus on EOR. Therefore, we set the objective to observe opportunity and challenge of using nanoflooding in Indonesia to achieve oil production to 1 million barrels per day by 2030. So the methodology of study we conducted through literature study, the information we get from journal, conference paper, report, speech, and discussion, and then we began to mapping the EOR status in Indonesia and also the chance and opportunity in Indonesia. Then we will briefly explain why nanoflooding might be considered to enhance oil production, followed by a field case pilot application between chemical and nanoflooding, and also concluding remarks. So, as a brief from Stosur et al. 2003, primary recovery through natural flow and artificial lift could have 30% or less recovery factor. And in secondary recovery using water flooding and pressure maintenance, they have 30 to 50% recovery factor, and the tertiary recovery using enhanced oil recovery, they will get 50 to 80% recovery factor. And the common EOR techniques are thermal, chemical, and gas injection, and other EOR techniques such as microbial, acoustic, and electromagnetic, mostly used in heavy oil. And the new technology, one of them is nanoparticles, as our objective to discuss in this presentation. So why common EOR techniques, also called as mature EOR techniques? It is because they already implemented in worldwide and already proven successfully. The first EOR techniques is thermal, with method steam flooding, in situ combustion, SECD, and electrical heating, with mechanism viscosity reduction, interfacial tension reduction, steam distillation, and oil expansion. The challenge is high energy cost with heat leaking to the unconsidered layer and heat loss from generator to reservoir. And the second one is chemical with material alkaline, surfactant, polymer, or combination of three of them with mechanism interfacial tension reduction with change wettability alteration and change mobility control. And the challenge is complex facility production for chemical preparation and separation that will cause this high cost and time consuming. The third is gas injection using material carbon dioxide, hydrocarbon, and nitrogen with mechanism change the oil swelling, miscibility process, and viscosity reduction. And the chance of this method or these techniques are poor swap efficiency due to high mobility ratio and resulting in gas fingering and early gas breakthrough. So this slide shows summary of achievable oil recovery based on three mature EOR techniques with different oil viscosity. Water injection already implemented worldwide, but the more viscous water, the more difficult to displace oil. So thermal injection effective in heavy oil viscosity. Chemical injection effective in light into quite viscous oil viscosity, and gas injection is effective in light viscosity because involved in miscibility process. This bar chart shows the EOR in worldwide. In thermal injection implemented in the USA and Germany, and gas injection implemented in the US and Canada, chemical injection implemented in China, and other EOR such as microbial implemented in worldwide with less than 5 cases. As mentioned earlier, thermal method is leading with 502 cases, and then gas injection with 379 cases, and chemical with 196 cases. And the application is mainly implemented in sandstone lithology with around 79%, and the rest were in carbonate lithology. So Indonesia has long story with EOR. In thermals, we started in 1967 until 1975 in Duri field, and started again in 1985 and successful until now. In gas injection, we have success story from Handil, phase 1 and phase 2. Phase 1 have cumulative oil 1.6 million barrels oil, and phase 2 have 1.2 million barrels of oil. In chemical EOR, we have success story in Minas with incremental 670 barrels oil per day in one well, and Kaji Semoga with incremental 10,966 barrels, followed by Meruap, Tanjung, and Limau. Besides common EOR techniques, there are also other EOR techniques such as microbial EOR, already implemented in Balam South, Bangko, and Minas, but the status is under study. And also fibroseismic in Kampung Minyak field, it is successful with incremental 10% from existing oil production, and the electrical EOR in Old Rimau oil field. The remarks is still in progress. So Indonesia have more than 650 oil fields. the oil fields still hold many oil resources. The national oil company PT Pertamina operates the largest number of oil fields. Based on Hendra et al. In 2018, SKK Migas already conducted top 34 fields priority for EOR fields, most of them located in onshore. And the method based on the preliminary screening, there are around 79% in chemical EOR, followed by gas injection EOR and thermal EOR. So there are general reasons for low recovery. First is poor reservoir characteristics, and poor understanding in reservoir that makes up optimal injection, and then a reservoir energy decline in production due to low support from aquifer, gas cap, water injection, or poor injection quality. Third is suboptimal development strategy that could lead suboptimal development plan. Fourth is suboptimal reservoir management plan, such as delay in EOR and also start injection while reservoir pressure below saturation. Fifth, due to flow assurance such as sand production, wax, and spalting. And last is asset life integrity that could cause low oil production such as facility bottlenecks and well integrity. So in this slide, I will show you the chance and the opportunity if we want to do EOR in Indonesia. Most of Indonesia oil fields already mature stage, 99%. And second is advance in simulation tools that it can calibrate software with own oil fields that we can have simulation before implemented EOR. And then limitation in material such as carbon dioxide and chemical in domestic market. Fourth is regulation and stringent environment that we have to do green EOR. Fifth is huge capital investment. For understanding of reservoir complexity such as segmented reservoir, it is very important. Seventh, lack of experts that understand A to Z EOR techniques and technology. Last is market oil price volatility and rising costs of projects. So in this slide, we would like to give lesson learned for screening EOR before field application, not only technical but also non-technical, such as economic evaluation and source of material. As we can see in Duri, the steam flood is ranked in number 1, and it is successful. And they tried to chemical injection and it is unsuccessful. While in Tempino, the gas injection is ranked in number 1 and it is unsuccessful. It is because the limited of carbon dioxide source, and they switch into chemical EOR. Besides that chance, the temperature also becomes chance in EOR, especially in chemical EOR with material polymer, because polymer only have maximum temperature 100 degrees Celsius. If more than that, the chemical will break the stability agent and polymer will turn into monomer. And based on Hutchinson in 1991, the reservoir closest to the Earth's mantle and volcanic areas that could cause increase in thermal gradient. As we can see, the normal thermal gradient is 25 degrees Celsius per kilometer. But in this calculation, in Tempino field, Kenali Asam, Minas, Klamono, and Handil have temperature gradient more than 25 degrees Celsius per kilometer, and it will be unsuccessful if we implemented EOR in this field. This following is geothermal gradient map of Southeast Asia from Indogeos 2021 to show consistency of the slide before about thermal gradient. The red color is high thermal gradient. So as objective of this paper, we would like to propose nanoflooding as an alternative to increase oil production in Indonesia. So what is nanoflooding? Nanoflooding refers to 1 billion meter size of fluids or nanofluids with small size. This particle could travel easily to the small pore throat and displace oil by chance the wettability, in example, to be more water wet if using hydrophilic nanoparticles. So this table shows the research on nanoparticles from EOR in the last decade that has unlocked potential to improve oil recovery. The research widely from 2 centipoise until 870 centipoise and 17 API gravity to 40 API gravity with lithology from sandstone and carbonate. So the concept of nanoflooding has been proved by this paper. In this slide, we would like to briefly compare between the chemical EOR using hydrolyzed polyacrylamide in Wainwright B field and nanoflooding using nanospherical polymer in Scofield field. Both fields located in Alberta, Canada, and have same oil pool. Before they compare the EOR, they already check the similarity in geological such as formation and lithology, and also the reservoir parameters such as porosity, permeability, and water saturation. The field case between chemical and nanoflooding, we summarize that there have 6 aspects to become parameter. First is water treatment, surface facilities design, wellhead injection pressure, operational consideration, oil cut, and capital cost. And the most significant difference in this field case is in oil cut and capital cost. Oil cut in chemical EOR, they only have 4% in incremental since kickoff, while in nanoflooding they have incremental 14% since kickoff in 6 months and have peak oil rate 25%. And the capital cost of the project in chemical, they spend 12 million US dollar, while in nanoflooding they only spend $800,000. It's only 7% from the chemical EOR. So what makes the chemical EORs is expensive is because they have to upgrade the injection facility. They have to process the chemicals such as polymer hydration, treated water tank, and the filtration. And this upgrade on facility design will becoming issue if want to implement it in offshore field. But in nanoflooding, they only have minor modification before proceed to injection well. So the concluding remarks of this presentation are nanoflooding is already proof in field pilot scale and also fast track for implementation, but it still needs more field cases to put high confidence level. And second, due to small size of material, nanoflooding could travel to the small pore throat and displace oil more effectively. And third is the availability in nanoflooding is limited, so the implementation in field scale is still limited. And the last one is based on the study, we strongly believe that nanoflooding is very attractive and has potential applicability to support the Indonesian oil lifting target to 1 million barrels per day by 2030. It is not only a dream. We also gratefully acknowledge to the Ener Club, a program by Enerca that encourages students and energy professionals to collaborate and work together in conducting research on topics related to the energy industry. Thank you for your attention.
Okay, let's start with the question and answers. We already have one questions already from Eric van der Wit. What kind of nanomaterials were used in the Canada example?
Okay, so thank you, Mr. Hendrik, for the questions. For the materials that they use in Canada for injection in chemical, they use hydrolyzed polyacrylamide, and in nano materials that they use nanospherical polyacrylamide.
Okay, thank you. And then the next question is from Guru, you mentioned that one of the challenges of EOR implementation is to understand the complex reservoir, and then any suggestion on the methodology, and then what about interference tests, and then that's about the heterogeneity, and the next question is about the challenges specifically for reservoir to implement the nanotechnology. Probably you can start with the first one about heterogeneity, initiation, methodology.
Okay,
About the
thank you.
complex reservoir.
Okay, thank you for Mr. Guru for the questions. So for the your implementation is very difficult because we have to understand the complex reservoir. Because as we know, the subsurface, we cannot saw the what happens in the below the surface. So we have to truly understand the complex of reservoir, because as I know from any field case that they have implemented the reservoir, implemented the EOR, they inject the chemical or they inject the material, then they have nothing incremental oil in the produced well, because they don't understand really well about the reservoir characteristic or reservoir, the big image of the reservoir. So for the suggestion methodology, that first, the methodology that I know, that if we have to reduce the risk in complex reservoir, that first we have to characterize first the big image of the reservoir, such as the faults, the petroleum reservoir, the gas cap, the water, and then after that, I think we could have a clear image about the reservoir before we inject the EOR material.
Okay, and the next question still from Pak Guru is for nanoflooding itself. Is there any specific challenges for specific reservoir, probably, for nanoflooding implementation?
I think the challenge, I think this material is still on test, as we can see on the slide before. If I'm not mistaken, in slide 24, there are a lot of research about the nanofluids in many conditions, such as various viscosity, in various lithology, and also various API, and also in various temperature. So I think for the challenge in any specific reservoir is still on test, Mr. Guru.
Okay. Pak Guru, if you would like to have a follow-up question, just type in a question and answer box. We go to the next one. It's from Pak Tito. Thank you for the presentation. Is there any field nanoflooding project already in Indonesia, or probably pilot? And then what kind of nanofluids used in that pilot or field implementation?
Okay, thank you, Pak Tito, for the questions. I think in Indonesia, I cannot say the company name and also the area, but there is a company that already want to implement this nano material, but they still on the project for the construction for water injection and then the production facility, but they still have to try to inject. Sorry, they still have to try the core flood or the lab test for the nanofluids to check the compatibility, stability, and the other characteristics.
Okay, that sounds a good news, at least close to real implementation in Indonesia.
Yes.
Next questions from Pak Andi Julius. Why the light oil steam flood project in Minas failed? Is it possible to apply nanoflooding in Minas? What is your opinion, Pak Aji?
Light oil.
Light oil steam flood.
Flood.
Light oil in Minas. I think that's in one of your presentation.
Yes. Okay. So the light oil in Minas, I think, based on the theory that I learned, that steam flood is really effective in high viscosity and the low API. So I think with the with the light oil, I think it's not compatible maybe. So I think that's why the reason why I think that is the reason why in Minas they failed to implement the steam flood in light oil. But okay, that's sorry, for the next question, is it possible to apply nanoflooding in Minas? I think it's possible.
Okay. Next question is from Teranun. Sorry if I misspell your name. How can we do nanoflooding for offshore field? What would be the challenge and what would be the cost for barrel for this technology?
Yes, we can do the nanoflooding for offshore fields because the reason why this is designed to be one of the cheapest EOR is because, as we can see in the field case in the slide before, between the chemical and then the chemical and the nano is the production facility, because in chemical they have preparation and separation water tank, and the nanoflooding we only have we only use treated tank for the water for the produced water. But the in offshore fields, I think it is still in research, because as we know, the offshore fields only have limited space. I think that's my answer for the in offshore fields.
And the cost for barrel for this technology, any reference?
Okay, for the cost per barrel for this technology, I think it's different in different field. So, but as we can see in the slide before about the field case, as we know, in Canada, the nanofluids only spends $800,000, while in the chemical they spend 12 million US dollar. So it's really different.
Okay. In case in Canada, right?
Yes, in case in Canada, I think it's in different fields. It will be different cost per barrel that implemented.
Okay.
Thank you.
The next question is from Pak Jufri from PHM. The comparison of EOR and nano on the cost-wise, mainly on the polymer treatment. What is the comparison with the surfactant only? I mean, I think because one of the benefits of nanotechnology is in polymer handling. So what about surfactant? Surfactant only compared to nanotechnology?
Okay, for the surfactant, I think the price is still below. Sorry, the cost. The cost is still below the. Sorry, nano. I mean, nano cost is still below the surfactant. As we know that I think the polymer is the expensive one, and then after that followed by surfactant below the polymer, and then after that nano or polymer, and then the price of nano is more competitive than polymer and surfactant.
Okay. I think it's already 30, but I think one last question from Pak Eric again, because the next session is still an hour from this one. Is the impact of nanomaterial limited to a polymer type of chemical, or is there also interfacial tension effect too by the nano?
I think it is depends on the carrier as a stabilizer. It can be polymer or it can be surfactant. Since nanoparticle cannot be standalone, they should have any stabilizer. If the carrier is surfactant, so yes, it will impact to the interfacial tension.
Okay, thank you, Pak Aji. So this is the end of this session 11. Thank you very much for the audience and participants for the questions and very active discussion. Thank you especially for the presenters and also co-authors. You've done a great job. And thanks also to my partner, John Jung. Thank you very much. I just want to remind everyone, we still have more sessions coming after lunch. Just jump and pick any session that you would like to join. And also, if you want to know more about the materials presented today, just download the paper, go to the IPA website. And also, if you want to download, you have to be IPA member first. And then don't forget to join tomorrow, not just today. We still have tomorrow session, the last day. And last but not least, thank you very much to our sponsors who make this happen. Thank you very much and bye-bye.
Platinum sponsor, Pertamina, melalui Pertamina Hulu Energi sebagai subholding upstream. Gold sponsors, BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver sponsors, Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze sponsor, Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian Petroleum Association and co-organized by Diandra Promosindo. Platinum sponsor, Pertamina, melalui Pertamina Hulu Energi sebagai subholding upstream. Gold sponsors, BP Indonesia, Mubadala Petroleum, Medco Energi, Schlumberger. Silver sponsors, Chevron, ExxonMobil, Inpex, Petronas, Premier Oil, A Harbor Energy Company. Bronze sponsor, Repsol, supported by Indonesian Ministry of Energy and Mineral Resources and Special Task Force for Upstream Oil and Gas Business Activities. Organized by Indonesian